So, we've been spending some time solving linear equations. I get it. You didn't actually spend a lot of time in 8th grade Common Core math because you skipped 8th grade Common Core math. So what you're looking at is x equals a number. So the expectation is that you mastered solving linear equations. I know not all of you have mastered it at this point, but it is expected that you will have it completely mastered within the next couple lessons. So in today's lesson, we're going to solve linear equations where the variable only occurs once. We will solve these equations by seeing the structure in the expression involving x and using the structure to undo what has been done to it. So we're going to look at 5x plus 3 equals 23. So list the operations that have been done to the variable x on the left-hand side of the equation in the order in which they have occurred. So when you look at this equation, we see that it is 5x plus 3 on the left-hand side. So the first thing that has happened was it has multiplied by 5. It's the first thing you do with x. And the second thing is then they added 3. So solve the equation by reversing what has been done to x. So first, we are going to write the original equation, 5x plus 3 equals 23. So what has been done first? Well, added 3 was done first, so we're going to reverse that. So instead of adding 3 to both sides, we're going to subtract 3 from both sides. So now we have 5x equals 20. Then the reverse of multiplied by 5 is divided by 5, so x equaled 4. So in essence, we have solved for x the same way that we have in the past. This is the most basic of all equation solving techniques. It's the most important solving technique in all of mathematics. Be clear on this. If the variable you are solving for shows up only once, identify the operations that have been done on it and reverse them in the opposite order in which they occur. So find the value of x that solves each equation. In each case, first identify the operations that have occurred to x, then reverse them, show each step. So what happened to x in the first one? So the first thing that happened to x was it was subtracted by 3. The next thing was then divided by 2. And the third thing that happened to x was added 7. So now we're going to reverse. So reverse of in the order backwards. So x minus 3 over 2 plus 7 equals 13. So the last thing that happened was added 7. So we're going to subtract 7 from each side. Let's erase the 5. Don't know where that came from. So subtract 7 from each side. So now we have x minus 3 over 2 equals 6. So the second thing that happened was divided by 2. So instead of dividing by 2, we're going to multiply by 2. So now we have x minus 3 equals 12. The last thing that happened was subtracted 3, so we're going to add 3. So x equals 15. Now looking at letter B, so what happened to x? The first thing that happened to x was add 1. The second thing that happened to x was multiplied by 4. Then the third thing that happened to x was subtracted by 2. So we're going to reverse. So we have 4 times x plus 1 minus 2 equals negative 6. So when we reverse, instead of subtracting 2, we're going to add 2. So now we have 4 times x plus 1 equals negative 4. Instead of multiplying by 4, we're going to divide by 4. So now we have x plus 1 equals negative 1. And instead of adding 1, we're going to subtract 1. So x equals negative 2. Often equations can be solved in multiple ways. Let's take a look at the next problem to see an example. So solve in two different ways. In the first one, we're going to reverse the operations, and the next one, we're going to do the distributive property first. So reverse the operations. So the first thing that happened to x was subtracted 4. The second thing that happened was multiplied by negative 2. The third thing that happened was added 8. So we're going to do the opposite. We're going to reverse the operations. So negative 2 times x minus 4 plus 8 equals 2. So first thing, or last thing that happened was added 8, so we're going to subtract 8. So now I have negative 2 times x minus 4 equals negative 6. The second thing that happened was multiplied by negative 2, so we're going to divide by negative 2. So x minus 4 equals positive 3. And the last thing that happened, or the first thing that happened was subtract 4, so we're going to add 4 to both sides, and x equals 7. Let it be, we're going to do distributive property first. So negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8, plus 8 equals 2. Then we need to combine like terms. 8 plus 8 is 16, so negative 2x plus 16 equals 2. And now we're looking at what has happened to x. So what has happened to x was that it was multiplied by negative 2 and then added to 16. So we need to do the opposite by subtracting 16 from both sides. Negative 2x equals negative 14. Then we divide by negative 2, and x equals 7. We should also be prepared to use this technique to solve problems where we must translate between English and mathematics. So we're going to set up some equations that translate the following verbal phrases into mathematics and then solve the equations. So 10 less than 5 times a number. So we're going to first look at 5 times a number. So that would be 5 times a number. And 10 less than that would be minus 10. And then results in is the same thing as equals. And then 35. What is the number? So we could look at this and go, okay, do you want to do it by stating what happened in what order? Do we just want to solve like we know? So we're just going to solve like we know. And we're going to add 10. So now 5n equals 45. Divide by 5, so n should equal 9. So looking at that, we need to check for reasonableness. What that really means is you're plugging 9n for the n. So let's look at 10 less than 5 times a number. So 5 times a number minus 10, does that equal 35? 5 times 9 is 45 minus 10, and yes, 35 equals 35, so it makes sense. Then we look at when 3 times the sum of a number and 7. So look at the sum of a number and 7. And then we have to do 3 times that. So when that is increased by 10, we now have the result is 4. So what is the number? So again, we can do distributive property. 3 times n is 3n. 3 times 7 is 21, plus 10 equals 4. Combine like terms, so 3n plus 31 equals 4. Subtract 31 from each side, and 3n equals negative 27. Divide by 3, so n equals negative 9. So now we need to check for reasonableness. So when 3 times the sum of a number and 7. So negative 9 plus 7 is negative 2. So when 3 times that is increased by 10, is it equal to 4? So is negative 6 plus 10 equal to 4? Yes, 4 equals 4. So it is true.